For my project, I use data from Strava. Strava is a social networking site for recording exercise-related activities. Strava does do a lot of analysis on the data natively, but I wanted to do a lot more complex analysis with my data. Strava does provide an API for downloading the detailed activity streams. For my personal data, this was 2.5 million rows of data. Once I filtered it for biking-only activities post-2020, I ended up with 1.35 million rows of data, which is what I used for this project. For my pipeline, I used AWS Cloud9, AWS S3, AWS Kinesis Firehose, AWS Opensearch, Kibana, AWS EC2, of course, and AWS Secrets Manager for storing my credentials. The project pipeline. As I mentioned, I used AWS Cloud9 IDE to run my Python scripts. The Python scripts downloaded all the data from Strava and saved it in pickle and CSV file formats. The files were, of course, stored in AWS S3. AWS S3 also handled all the exception logs, etc. Next, I created a Kinesis Firehose stream. I opted to use this rather than Kafka streams because I was already in the Amazon AWS environment. I also spun up a EC2 instance, a separate EC2 instance than the Cloud9 environment. And that EC2 instance ran a Python script which took the CSV file and created JSON documents for each row. Those JSON documents were sent to AWS Kinesis Firehose. Multiple EC2 instances could have been spun up if more throughput was required. Here you can see that the maximum throughput is the red line. I'm only using about 10% of what I'm allowed by AWS. It took about 5 hours to send 1.35 million rows of data at about 100 rows per second. You can see that in Opensearch, they seem to go in batches because you can see these peaks and troughs. In AWS Opensearch, I created a domain. This is the domain to which AWS Kinesis Firehose was sending all the data. And within the domain, I created an index. And you can see that this index has 1.35 million rows of data in it. And now for the fun part of the presentation, Kibana Dashboards. Finally, we can visualize all the data we've been processing. So I really enjoyed making these dashboards. This is a dashboard where we can see outdoor versus indoor riding, average power, average heart rate, how much time I spent indoor versus outdoor, power, heart rate, cadence, speed distributions. I really enjoyed these heat maps, which show a correlation between heart rate and power. And this one shows a correlation between cadence and power. So you can see how cadence and power are correlated and where I spend most of my time as well. We can filter this dashboard for over 200 watts. We can even add an additional filter for over 170 beats per minute. So this is fairly intense for me, so I don't spend a lot of time here. But we also have geolocation data. So I can see I can create a heat map of all my rides around Boston. But the geolocation data can also be filtered. So if I filter the geolocation data for power over 450 watts, which is a sprint for me, you can see where I sprint in Boston, and you can see that in Strava's ranking, I'm currently ranked number 2 for this particular sprint. Any questions? And thank you.